Let's build a small coding agent setup for a real project. The example we'll use is a billing bug. An admin opens the billing settings page and sees the free plan, even though the team account has an active pro subscription. If you give a coding agent only that sentence, it can still try to help, but it has to guess a lot. It has to guess how billing ownership works in your app, where the settings page lives, what files are generated, what tests matter, and what the team has already learned from previous bugs. So before asking the agent to fix it, set up the project so the agent has the same basic operating instructions a human teammate would need. Start at the root of the repo with an agents file. The exact file name can depend on the tool, but the purpose is the same. Write down the repo-wide rules the agent should follow every time. For this example, the first section is about search and edits. Tell the agent to use fast text search before broad file reads, to inspect existing patterns before adding helpers, to use the project's normal patching workflow, and to avoid reverting changes it did not make. The second section is about project boundaries. Tell it not to start dev servers. Tell it where temporary artifacts go. Tell it not to edit generated files. Tell it not to add a new UI library without approval. Then add the billing specific rules. This is the part that makes the later bug fix work. Billing belongs to the account, not to the individual user. Before changing billing code, the agent should read the billing notes in the project memory folder. It should also avoid logging provider identifiers or payment-related data. Finally, add the verification commands. For this repo, billing changes should run the focused billing test suite, and TypeScript changes should run the typecheck command. The final response should say which files changed and which commands ran. Keep these rules direct. A vague rule like "be careful with billing" is easy for a model to satisfy without changing much behavior. A concrete rule like billing uses account identity, not user identity, gives the agent something it can apply while reading code. Now create a skill for this kind of bug. A skill is a reusable workflow. The repo instructions say how to behave in this project overall. The skill says how to handle one repeated type of task. For this bug, create a billing debug skill. Its trigger should be any task about billing, subscriptions, invoices, checkout, plans, or account entitlements. The workflow should be simple. First, read the billing memory file. Then search for billing, subscription, checkout, account identity, and user identity across the source and tests. Then trace the request from the billing page to the server-side action and then to the database query. After that, the skill tells the agent what to check. Is the query scoped to the active account? Is it accidentally using the signed-in user as the owner of the subscription? Is anything sensitive being logged? Is there already a focus test for this behavior? The final steps are to add or update a billing test, run the focus billing tests, run typecheck, and report the result. That is the kind of task that belongs in a skill. You should not have to type the whole billing debugging checklist every time a billing issue appears. Next, add project memory. I prefer project memory that lives in plain markdown files inside the repo. For this example, create a billing notes file under a docs folder for agent memory. This file should say that billing ownership is account level. It should say that users can belong to multiple accounts. It should say that subscription lookup must use the active account. It should say that an admin role does not mean the subscription belongs to that user personally. Then add one short incident note. In a previous bug, the billing settings page showed the wrong plan because the code looked up a subscription using the user instead of the account. The fix was to query by the active account and add a regression test. That memory is useful because it is inspectable. A human can review it, edit it, delete it, or improve it in a pull request. The agent is not relying on a vague memory from an old chat. It is reading a project note that the team chose to keep. Now the bug fix request can be much shorter. Ask the agent to fix the billing issue, follow the repo instructions, use the billing debug skill, read the billing memory file, run the focus tests, and report the result. If you have a GitHub MCP connected, the agent can also read the issue directly. It can inspect the comments, linked pull requests, labels, and failing checks. If you do not have a GitHub MCP, you can paste the issue text manually. The rest of the workflow still works. The agent now has a clear path. It reads the repo instructions, it loads the billing debug skill, it reads the billing notes, it searches the source and test folders for billing and subscription code, it finds the billing settings action, follows the data flow, and sees that the lookup is scoped to the signed-in user instead of the active account. The important point is the shape of the mistake. The page is account scoped, but the query is user scoped. That is why a team admin can see the wrong plan. After the code change, the agent runs the exact commands from the repo instructions, the focus billing tests, and the typecheck command. The final response should be plain and specific. It should say that the billing action was changed, that a regression test was added, that the billing lookup now uses the active account, and that the focus billing tests and typecheck passed. If any command was skipped, it should say why. That is the first complete loop: repo rules, task skill, markdown memory, code change, regression test, verification report. Now add a second skill for database migrations. This one should trigger when the task involves migrations, backfills, indexes, constraints, or schema changes. The workflow should ask practical review questions. Is this safe on a large table? Does it add a required column without a backfill plan? Does it create an index in the safest way your database supports? Is the data backfill separate from the schema change? Is there a rollback path? Has this migration already shipped? And if so, should the agent create a new migration instead of editing the old one? The output for this skill should include lock risk, rollback path, deploy order, and verification command. That turns migration review from a vague request into a checklist the agent can follow each time. Then add a front-end QA skill. This one should trigger after user-facing UI changes. The workflow should tell the agent to reuse existing components, use existing design tokens, check mobile and desktop layouts, verify loading and empty states, and make sure text does not overflow buttons, cards, tables, or form controls. If screenshots are needed, they should go in the temporary artifact folder from the repo instructions. The skill should also name the lint command and the focused component test command. Again, this is not complicated. Now add MCP where it actually helps. For documentation, connect the docs MCP server. When the agent updates API usage, the repo instruction can tell it to consult current docs first. That prevents it from relying only on old memory when request shapes, model names, or recommended patterns change. For GitHub, MCP is useful for issues, pull requests, comments, and CI status. The agent can start from the actual issue, inspect the branch state, and summarize failing checks. For Figma, MCP is useful when UI work needs design context. Instead of guessing from a screenshot, the agent can read frame names, component names, text, spacing, and color information. For internal tools, keep the MCP surface narrow. If you have a video editor, expose actions like reading the current project, listing assets, reading the timeline, or placing visual clips through the app's own validation layer. Do not expose raw database writes when the app already has safer operations. The rule for MCP is practical: give the agent the context or action it needs, but keep the boundary clear. At this point, the minimal setup is small. You can build this gradually. Add a rule when the agent repeats the same mistake. Add a skill when you keep explaining the same workflow. Add memory when a project decision should survive beyond the current chat. Add MCP when the agent needs current external context or a safe tool boundary. That is all. You are just giving meaningful instructions. Thanks for watching.